Hey everybody, we're going to talk about congruence classes. So this is one of the parts of modular arithmetic that's kind of important. So um, what we're looking at here is we're going to talk about the congruent. To give an example, we're going to talk about the congruence class of 3 mod 5. So essentially, this is the way we would describe this. The mod kind of describes the system we're looking at, and we're talking about the specific number 3 in this case. So some of the numbers that are associated with this are, -7, -2, 3, 8, 13, 23, and so on. So what we're essentially saying is that all of these numbers in this set are equivalent to 3 in this modular system. Okay? And the reason we can say that is because of this part right here. Is what's happening is when we divide by 5, we get the same remainder. Okay, the negatives may not seem like that, but we'll get to that piece later, and we'll look more at that on why the negatives also fit that. Essentially, what we're saying is all of these values are equivalent to one another. Okay, we're creating this kind of world of mod 5. We're essentially inventing a new number system, a very simple number system where we're going to take all of the integers and we're going to reduce them to essentially 5 numbers. And it turns out that it's going to be 0 through 4 because we're talking about the remainders of 5. So in this particular example, we're looking at a remainder of 3. A couple of examples you might want to think about, like if that doesn't quite make sense to you, there's a couple ways we can think about this. One of them has to do with if we use fractions. So like if I think about fractions for a minute, if I consider the number 1 or the fraction 1/2, well, we know that we can write 1/2 as 2/4, or we could write it as 3/6, or any number of different things. So what we essentially could say then is that the set of all of these fractions, 1/2, -6 over -12, we could even say pi over 2 pi, 43 over 86, and so on. This particular set is 1/2. It's represented by the number 1/2 because all of the things inside of there are equivalent to 1/2. So that's a similar thing. The other example that I want to use is for those of you that are familiar with trigonometry, which most of you probably have taken some trigonometry at this point. It's the notion of coterminal angles. So you think about it as you go around the unit circle. So if I think about my unit circle here, and I go around this thing, let's say, for instance, I have the angle pi over 3. Okay, so put that over here. Well, if I go around the circle all the way and then stop at pi over 3 again, I actually have 7 pi over 3. And if I go the opposite direction to get to this point, then I'm at -5 pi over 3. Now, are these angles all the same? No, obviously not. However, they do all have the same terminal side. If we think in terms of trigonometry, they have the same terminal point. So we would say that all of these angles, in one sense, are equivalent to pi over 3. We use the word coterminal in trigonometry, but same basic idea. So what we're doing is we're taking a class so in the original problem up here, this congruence class, we're taking all of these numbers, these integers, and we're reducing them to this notion of this is equivalent to 3. And this is going to make things a lot easier when we're working on sets of numbers later on. So we're essentially taking a whole set of numbers, a class of numbers, and we're assigning them a single digit. And so that's what's happening in this expression right here, is we're basically taking this whole set of numbers and any of the numbers that would also go inside of here, and we are essentially saying that they're equivalent to 3. And that's what congruent classes are going to do for us, is they're going to allow us to take all of these different numbers and reduce them to a very, like a finite set of numbers. And the set of numbers that we choose can be small. If you think about it, binary numbers are technically that kind of a number system, either on or off based on what you're doing and where you put those values. We could have we could have a modular mod 1000 if we wanted to. So the choice of how big our mod is really only limited by what we want to do with it. Anyways, that's what congruence classes are. We'll be talking more about these. And if you have any questions going forward, make sure you ask. And thanks for listening.